Well, hello and welcome to thermodynamics. This is Ron, and today's video is on the first law of thermodynamics. In the first law, the first thing we start talking about are the different kinds of energy. Now, you've probably heard before that the first law of thermodynamics is also known as the law of conservation of energy. Again, there are 5 kinds of energy. If you've had a class from me before, you probably know this. And the first kind is potential energy. You have seen that in physics and dynamics. The second kind is kinetic energy. You've seen that in physics and dynamics. A third kind is work, and you've seen that before. The 2 new kinds, if you're new to the thermal sciences, are internal energy and heat transfer. So each of those is worth a little bit of time talking about. I put these into 2 columns because we give these 2 different kinds of energy, these 3 one kind, and these 2 another, different names. These energies we call stored energies. Now what it means with the stored energy is that an object can have this kind of energy. A mass can have this kind of energy. If I were to take a book and lift it up 10 feet, it now has more potential energy. A car driving down the road has kinetic energy. In fact, you know that the equation for those, mgh, 1/2 mv squared, they both have mass in them. So this is the kind of energy that an object can have. Internal energy is the energy associated with the molecules in that mass. If the molecules are moving really fast, it's got a lot of temperature. That temperature is representative of the internal energy of the mass. So if you take a cup of coffee and you heat it up, what you're doing is you're putting energy in in the form of heat, and it goes in and stores up in the form of internal energy. So that's internal energy. This next energy is called transient energy. Now, transient energy is energy that cannot be stored. It can only go from one system to another. Today is a cold day in Minnesota. Inside my house, the temperature is 70 degrees. Outside my house, let's check. The temperature is 0 degrees. There is energy flowing through the walls of my house. We call this energy transient energy. It is flowing from one system to another. Flowing from the system of my house to the system of outside, it's crossing that boundary. Work and heat are both examples of stored energy. All right. Well, the first law is how all of these things interrelate. Now what I use is I use something called, I refer to the first law as an energy balance. And I think of it like my checkbook. I've got my stored energies, potential energy, kinetic energy, and internal energy. I'm going to use the symbol sub-zero for before something happened. So this is my balance at the beginning of the month. Then I can add in heat and work. Or I can subtract heat or work. And for some reason, we use in and out for heat transfer, and on and by for work. It's a convention. And then after the event, I'll be left with a final potential energy, final kinetic energy, and a final internal energy. Start with some stored energy, transient in, transfer in some energy, transfer out some energy. At the end of the day, I'm left with some final energy. This is the first law of thermodynamics. It is the law of conservation of energy. It is known as an energy balance. So the next thing we're going to talk about are a few systems. One kind of system is a closed system. In a closed system, we'll let my house be a closed system. I start with some initial potential, kinetic, and internal. Transfer in some energy, Q or W, transfer out some energy, Q or W, and then at the end I have some final energy. If I transferred in heat, for example, the temperature in my house might go up, and I would have a final internal energy that was more than my initial internal energy. Closed system. In a closed system, no mass crosses the boundary. Only energy does. In an open system, and if I were to open the windows and the doors in my house, I can have mass flow in or mass flow out. In an open system, both mass and energy can cross the boundary. In an open system, both mass and energy can cross the boundary. One of the systems that gets talked a lot about in thermodynamics is the power cycle. Now the power cycle, also known as the Rankine cycle, converts a heat input to a work output. Burn coal, turn a generator, spinning shaft, that's work, turn it into electricity. We're converting heat into work out. Now I encourage you to take an advanced thermo in advanced power cycles. Very interesting and very useful. A simple Rankine cycle has 4 parts: a boiler, a turbine. These are not drawn to scale at all, by the way. A condenser, and a pump. A boiler, heat comes in. A turbine, work is done by. A condenser, heat goes out, and a pump, work is on. If we draw the boundary, and what determines whether a system is open or closed is the boundary, and the person who gets to decide the boundary is us. If we draw the boundary like I just did, this is a closed system. No mass enters, no mass leaves. It's only energy crossing the boundary. But I can choose my boundary around just the turbine. And now mass enters, mass leaves, and energy leaves. And the turbine would be an open system. We'll get an opportunity to talk more about this and to talk about the different kinds of systems. The last thing I'll say is that while I just applied the conservation of energy to a mechanical system and turns out an electrical system, it works for anything. This works for the can of pop that you might have on your desk right now. It works for the cup of coffee that you have. It works for your human body. It's the law of conservation of energy, and it works in all cases. So, the one thing that I ask of you as you come to class every day after having watched a video is that you take time to bring questions. You look back over this video and all the things I talked about. What did you understand? What didn't you understand? What would you like to understand better? Bring those questions to class every day. Thank you very much.